All right, I think we are good to go.
Great. Thanks for the introduction, AJ and Akshay. You'll have to send me a slice of pizza through Arden.
Yeah.
So a little bit about myself. My name is Davide, call sign Whiskey 6 Delta Golf Echo. I'm a Cal Poly SLO alum. Got my bachelor's in mechanical engineering and graduated back in 2022. I was part of the Cal Poly Amateur Radio Club from 2017 through 2022 and helped out with a large number of projects at my time at Cal Poly, which in large part contributed to kind of what I know today for RF and for Arden. I kind of helped do the initial Arden build out in SLO County at Clark Valley all the way back in 2021, and currently I'm helping manage the SLO Arden backbone and the Arden network, as well as the Cupertino Aries Arden services. So a little bit about Arden. What is Arden? Arden stands for the Amateur Radio Emergency Data Network. Um, So Arden effectively is a network that's slowly been growing over time. Some of you may be familiar with the traditional two-way radio systems in the VHF band and the UHF band. What Arden is it's taking that communication and it's moving it up into the higher frequency ranges so that you're able to carry more data effectively and you're able to run a wide variety of services that you would otherwise not be able to run or be very limited in how you're able to run them on traditional VHF and UHF networks due to much lower bandwidth and data rates. So kind of an overview of today's presentation. We're going to go over a little bit more in depth what Arden is, the current status of the network across the San Luis Obispo County, as well as kind of some planned system upgrades that we have that will be going on over the course of the next year or 2 years. And towards the end of the presentation, we'll also do a system demonstration of some of the services that are available. The idea with the presentation is I want to keep it open-ended. So if at any time anyone has a question, just raise your hand. Hopefully, I'll be able to see you from the two camera feeds. And I just want to kind of keep it open-ended so that whatever students are kind of interested in the different parts of Arden, I can kind of help answer those questions because there's a lot of different aspects that go into it. So I think there will be a lot of different areas of interest from different students with their different backgrounds. So let's stay before ARDN stands for the Amateur Radio Emergency Data Network. And the mission statement of ARDN is to provide the amateur radio community with a quality solution for supporting the needs of high-speed data in the amateur radio and emergency communications field. Uh, the equipment used for Arden is probably a lot of equipment that you are already using in your day-to-day for just Wi-Fi in your house. A lot of Wi-Fi access points are supported on Arden. What Arden is it's a firmware that gets flashed on top of these devices, and it's based on OpenWRT. So if any of you have tinkered with routers before and you've flashed OpenWRT on top of a stock firmware, Arden is essentially OpenWRT with a different UI and some different routing protocols, but the core fundamentals are kind of the same there. The software is open source and has a wide number of people that help maintain it. And there's a constantly growing list of devices that are available and supported on Arden. A lot of the devices are Part 15 devices, which means they're running in unlicensed frequency spectrum. So the usual 2.4 and 5 gigahertz frequency bands that are available on normal consumer hardware. However, when you flash these devices with Arden, what it effectively does is it removes whatever software lockouts are on there to keep them compliant with Part 15, and it allows you to run at higher power ranges and at higher frequency ranges compared to traditional consumer equipment. The benefit with this is it enables you to get out of the noisy environments that all the normal consumer devices are in. And with the higher power, it also allows you to make some longer range links that you otherwise wouldn't be able to make. The downside with Part 97 is you are not allowed to run any encrypted services over that link or network. And in today's day and age, there's always more and more devices and services that are running over encrypted connections. So it brings about a significant bottleneck and hurdle that we're kind of constantly working around. So this is the current coverage as of today in San Luis Obispo. This was taken a couple months ago, so some nodes we have more nodes on the network now than when this picture was taken. But our coverage stretches from as effectively Paso Robles all the way down to about the Lompoc area, and this is kind of set across several different sites. We have Paso Robles is one of our key sites. We have some radios on Tasajara Peak as well as Cuesta Peak. And then moving south, we have the Pismo Heights sector, which is the sector that Dave is connected to, as he was alluding to earlier. We have Tepesquei Peak, which is currently active, but we have no active users connected to that. We have the Site 3, which is West Orcutt Hill, and over here we have Harris Grade East, and then down here we have Gravel Peak. All of these are higher hilltop sites that effectively let you view down into the valley floor and connect. One of the challenges with Arden is because it is 2.4 and 5 gigahertz, you have to be fully line of sight in order to be able to connect. And it doesn't take much to actually break that connection. If you have a tree branch with some leaves in the way, that could potentially stop you from being able to actually connect up to the sector. Now, that being said, if you do have a clear line of sight, it can actually go a lot further than you think. We have several links in SLO County for the backbone that are upwards of 20 to 30 miles apart and have been running with minimal to no downtime since they were first set up in 2021 and 2022. So there's a mix of different hardware that's available on the mesh right now. There's the 802.11 standard. We have A and N hardware, which is kind of what the Arden protocol first started using. And more recently, we've been bringing in more support for new AC hardware. The benefit of the AC hardware is it has higher bit rates, so you're effectively able to pass more data on that same connection compared to the A or the N hardware. It's also hardware that is not obsolete, so it's a lot easier to get replacements or spares. A lot of the older hardware that we used to set up the link was recovered from different hilltops that have been upgraded to newer hardware, which worked well at the time just to do a proof of concept and get the network on the air. But as kind of the needs have been growing and we've been getting more users on the air, we've been moving towards the newer hardware just so that we're able to keep up the level of support and data backhaul needed for the network. Any questions so far? Great. This is a picture of the current install that's up on Cuesta Ridge. So down here is the San Luis Obispo area. You have, I believe this is Mount Madonna, and then here you have Bishop Peak, if I recall correctly. So as you can see, Cal Poly is unfortunately a little bit shaded because it's right behind this ridge line. So this is one of the challenges that we have in that if you had a normal UHF or VHF two-way radio system, you could just put an antenna up here, and even though you have a little bit of shading from the hilltop, you probably wouldn't really notice that shading all that much because the signal would be able to get over or around that hillside pretty easily and into the repeater. However, with Arden, if you have a hill in the way, there's no way that you're going to be able to connect. And so one of the main challenges that that brings is you need to have a lot more kind of fill-in nodes that are scattered throughout the different hilltops that are able to fill in the valleys. Uh, Most of our hilltop sites consist of three main elements externally. We usually have one or two site cameras. These are used both kind of in conjunction to the alert wildfire camera for us to be able to see kind of if there's any wildfires or kind of issues nearby. And we also bring them onto a publicly available website. So they kind of act as webcams for SLO County for people to be able to connect and view the different cameras around the county of San Luis Obispo. The second part that we have is we usually have a backhaul dish. The backhaul dish is used to carry large amounts of data from either the valley floor, where we have kind of our original internet connection that will allow us to connect out to other cities or states where we don't have direct line of sight access to connect to them via RF, or to other hilltop sites. And this is an older node. This right here is a newer node that is running AC hardware. So they kind of come in different shapes and sizes. Generally, the larger the dish is, the more gain that you have for that connection. Uh, Higher gain will allow you to do two things. It'll allow you to have a higher signal to noise ratio, which means you'll be able to pass more data on the network over a given link compared to a lower signal to noise ratio connection. The other benefit is it also allows you to make a much further link. So these dishes are generally good to do somewhere between 10 to 15-mile distances. For the links where we're spread apart about 30 miles, the dishes can go upwards of 3 to 4 feet in diameter for us to be able to have enough gain to make that connection. The final part that we usually have on the hilltops is this little device here, which is our sector access point. This is the back view, so you can see the radio and then the dishes in front. This is a front view of the same sector, but on a different site. And these come in different beam widths. They come all the way from 30, 45, 60, 90, and 120-degree beam widths for coverage. So these will generally be mounted on the hilltop, and this is what the individual users that are located in the valleys will connect into in order to get onto the network, so that we separate the user connections from the backhaul connections to minimize interference and maximize the network performance. Here you can see one of the cameras that we have mounted up at the site. This is actually up at Clark Valley, over near Los Osos. And this was the first install that we did. So everything you see here is the original hardware that we used when we first set up the site all the way back in 2021.
I have a question.
Yes.
Why don't all the sites use big dishes?
It's a combination of different factors. The first one obviously is cost. Larger dishes mean that they cost more to procure. They also take up more tower space, and in a lot of cases, uh, tower space comes at a big premium, and we tend to be secondary users of the spaces for the backhaul. So we try to minimize our footprint as much as possible. And in the spirit of amateur radio, you only really ever want to use as much power as is actually needed to make your connection. So in our case, also with the dishes, we only use the size dishes that's actually needed to make the connection. We can go bigger if we have a surplus of equipment. Sometimes we've installed bigger dishes than what were necessary. Because if you do have a bigger dish, you can go sometimes to a higher bit transfer rate, so have more data passing through compared to if you had a smaller dish on the same link that is still able to make the connection. But generally, cost and kind of space availability are the two main constraining factors for that.
You know where to point the dishes.
What was that?
How do you know where to point the dishes?
Where to point the dishes? Uh, let me pull that up. One moment. So there's a number of different link planning tools that are available. One of the more common ones that is used, at least for what we're doing in Arden, is called the ISP design tool, which is from Ubiquiti. So this is the project that I actually have for the San Luis Obispo link. So most of these are the backbone links, and I have a couple of the sector links in here as well. So what this does is you first find kind of the location where of the two sites that you're trying to link. And what this tool does is it has all the LiDAR topographical data that's imported into it. So if I were to pull up a link, say from Cuesta to Orchid Hill, and you can see that's about a 40-mile link that we're doing. Uh, you can see all the topographical data here on the bottom of kind of what obstructions may be in the way. The one thing this doesn't account for, however, are trees. So if you do have trees in the way, you may not necessarily see it on the map, but you see it kind of later down the line. So generally, what we first try and do is we try and just scope out the link with a tool to see if it's even feasible or if we have a major kind of blockage in between the sites. And then we'll usually do a basic test of just bringing a couple of nodes up to either hilltop and we point them towards each other. In terms of knowing kind of what your tilt and your azimuth needs to be, the tool does calculate what those values need to be for each dish. So then you can just use a compass or an inclinometer on your phone to kind of set the antenna to those values as a rough starting point. Some of the newer antennas actually have accelerometers built in that are able to pull the data directly from the design tool and then help you actually align it to what uh, the set specification is supposed to be. Is that another question?
And some of them have a tone, so once you
Correct.
get them close, you can aim them for
Yeah,
peak.
they'll have a alignment tool a lot of times built in, so they'll show you a plot of the signal strength, and there's also a tone that plays. And as you get a stronger and stronger signal, the frequency pitch of the tone increases to tell you that your effectively your signal is getting better. Cool. Other questions? Yes, go ahead.
This not like used for testing, it's not live.
Can you repeat that for me,
Um,
Akshay?
I'm sorry. This is all used for testing, no point, like where you place, carbon nodes, and not necessarily the actual experimental data, correct?
This is what helps give you the initial data of if the link is even going to be feasible or not. And then once kind of you know if it's feasible or not, you'll usually have a person drive up to either hilltop site and you'll try to make the link. Sometimes it's just a temporary link of you have someone on a car one side of the hill, someone parked on the other side of the hill. They just put the two antennas on a pole and point them towards each other and see if they can get them to link up. And then if they are able to do that, then kind of they go about actually figuring out where it's going to be mounted on site and getting all the hardware that's actually required to get it mounted permanently. Other times, if it's a link where you see just two huge valleys and you have clear line of sight with binoculars from one tower to the other, you may just physically mount them on the tower and just align them, and that's kind of your permanent installation. So it kind of depends on a case by case basis. Right. Anyone else? Awesome.
Do you have more slides or is this question?
Yeah, no, I do have more slides.
Okay.
So this is on the inside of the vault. This is generally the hardware that's used to actually run the links. So the picture that's here on the right is our rack shelf that's located up at Clark Valley. And then the picture that's here on the left is a rack shelf that I helped one of the Hilltop users who runs a lot of the South SLO County AREDN backbone build, Chris Hill, Kilo 7 Alpha Zulu. So what you see here is a PoE switch with PoE is power over Ethernet. That's at bare minimum. If you have nothing else on the Hill site, you just need a PoE switch that can provide power to the nodes and connectivity so that they're all able to talk through to each other. But a lot of times the hilltop sites will have other equipment there as well. Sometimes you'll have repeaters or you'll have APRSI gates or kind of different services that are located on the backbone. Part of the advantage of having them located on the hilltop is that you're already directly connected to the backbone on the high-speed network, so you don't have to have an additional point-to-point RF connection for that data to get on the backbone network and get distributed to the users. The downside is depending on how easy or difficult it is to get to your site and how far away it might be to get to your site. If you have any sort of system issues, it may be a while before you're able to get things repaired or get things back on the air. So there's advantages and disadvantages to doing so. The switch that you see right here is a 8-port Ubiquity switch, which is one of the more common ones that we have on the network. The two down here are a Netonic switch. This switch is a lot more common for different WISPs or wireless internet service providers in the San Luis Obispo County area. The nice part about these Netonic switches is that they can natively run on a wide voltage range from 9 all the way up to 72 volts. So effectively, as long as you are able to provide them as power supply, you can effectively run them on batteries and have a nice battery backup on site should you lose power, which with the high wind events and the PG&E PSPS events, blackouts on hilltop sites are becoming more and more recurrent and for longer periods of time. So being able to have that backup is not just a nice to have, but kind of a critical function, if you will, especially because it is an emergency data network, and chances are in times of emergency, power may be one of the first thing that goes out, especially at a lot of the hilltop sites. But as I was saying earlier, this equipment will often be tied into other devices on hilltops. A lot of different repeaters are cross-linked in the San Luis Obispo County through the AREDN network, so that effectively, if I were to key up a repeater in San Luis Obispo, it might key up another repeater down in Lompoc where I don't have line of sight coverage to get from San Luis Obispo into Lompoc, depending on where the repeater is located. But through the link of the AREDN network, they're both able to come on the air, and then I'm able to talk with people in kind of different areas of uh, San Luis Obispo without needing to use the internet or rely on the internet should that go down for whatever reason. Talking a little bit more about some of the mesh services that are available. So there's a lot of different services that are available on the mesh. I've made kind of a nice little list here on the side, but it's by no means a complete list. There are a lot of different things that you can do with the mesh, and really if you can do it at home, and you can do it on the internet and you have a way to self-host it at home, chances are you can also do it on AREDN as well, provided it doesn't require internet or cloud connectivity. So, one of the things that we have is Mesh Chat and email and WinLink. So email generally would be connected to a cloud-based server. With AREDN, a lot of people will run servers locally on the network, so you're still able to send email messages or send attachments via email or via WinLink radio, but without actually needing to go through the internet. You go through the AREDN network instead to be able to pass this information. There's also the voice over IP phone services. I have a picture here on the side of the current server that's running the San Luis Obispo PBX or Public Branch Exchange server. So we have a connection to the North Bay area, a connection to Ohio, and a connection to Cupertino. And although technically we only really need one, we have three connections for redundancy. And these sites are also linked to other sites across the backbone network. So effectively, with these three links, I'm able to talk to people in Ohio or all along the East Coast or kind of south in Florida or the other side of the world in Switzerland, really anywhere that there is an AREDN phone server that's there is then on the AREDN network. And we have what is called mesh phone. So mesh phone is effectively our own kind of custom version of being able to link these different servers together so that we have a standardized way of being able to come up with phone extensions and phone numbers for dialing people. Because if everyone made their own standard with all the different servers that we have, we'd have probably 400 different standards to keep track of, which would not be feasible. Some other things you can do is you can do video conferencing. There are some open source versions of things like Skype that you can use that are able to run locally without needing to rely on the cloud. As touched on it earlier, we also have repeater linking that's available. We have the cameras for site awareness. This picture here down below is actually the picture from the camera that I showed earlier overlooking Los Osos and Morro Bay. And you can't see it very well here, but on a clear day, you can easily see the Morro Bay Towers and all the way up the coast to Cayucos and beyond on the camera. So it provides both nice awareness as well as kind of a nice view for the public, both for kind of fire watch and just general awareness of even things like weather moving in. And then the last service I'm running is the site monitoring and alerting, which is the picture that you see up here above. I'm able to on the server run a series of different services that effectively pull data from all the different devices that are on the AREDN network. And it can, depending on how I configure it, tell me things like if I'm having a network outage or if a device has dropped off the network, or if for whatever reason, all of a sudden I'm seeing a big slowdown in the network, that may indicate to me that maybe I have hardware failure or maybe an antenna's gone out of alignment and I need to go check it. And one of the things that we've done is we've implemented automatic emails so that if nodes do go down for more than half a day at a time, it'll send out an automatic email saying, hey, this node is offline. Please go and check and see what's going on. And if that node does then come back online before you go up there, it'll send an email out saying, hey, this node is now back on the network and functioning properly again as well. Yes.
I tried to look at some of the cameras on Arden, and quite a few of them are passworded. Is there a standard password that they use, or do you have to contact the owner?
We don't have a standard password at the moment, because a lot of the cameras are managed by different users. We do generally have all the cameras pulled onto single page so that you're able to see them all from the single page. Unfortunately, because the slow Arden server was down for the last couple of weeks, that page has been inaccessible. One of the things that we are looking at doing is creating a backup server that is able to kick in if we ever lose the primary so that those services can remain online and have a certain level of redundancy.
Thank you.
Absolutely. Other questions? Cool. So talking a little bit about the next steps and kind of the future of the Arden network for SLO County. So the Cal Poly Amateur Radio Club was able to apply for and was accepted for a $77,000 grant to help execute a full backbone upgrade for San Luis Obispo County. This consists of several different things. We will be upgrading a lot of the radios to newer hardware and larger dishes that allow for both a more stable link and higher speed. A lot of the sites that don't currently have battery backup will be getting battery backup so that they're more resilient in terms of power outages or public safety power shutoff events. And we'll also be adding a lot more cameras to the different hilltop sites to provide some better coverage and views throughout San Luis Obispo County. So those are kind of some of the major items that we'll be doing. One of the main goals of this grant is we're actually trying to bridge the gap between the Los Angeles Arden network and the Bay Area Arden network, which is two of the more complex and interconnected networks of the Arden system. To do that, we currently do have a link here, which is at Santa Ynez Peak. And there is work in progress from the Los Angeles Amateur Radio Group to be able to connect up to the Santa Ynez Peak with one of the ARDC grants. And then from the north, there is a different group, the Whiskey Bravo 6 Echo Charlie Echo WB6 ECE repeater group, who is working on extending the microwave network from the Bay Area down to Williams Hill, which is this top node here. So with those two grants going on and our third grant, once we complete the microwave links, we'll effectively have a path via microwave RF from Los Angeles all the way up to the Bay Area, San Francisco, which to my knowledge is going to be one of the longer point-to-point links that's actually on the Arden network, because a lot of times there's different cities that will have kind of a large cluster, but there's no solid RF connection from one city to the next, so they're all cross-linked through the internet. But if for whatever reason that city loses internet access, at that point they're pretty much isolated and they're islanded off from the rest of the AREDN network. So this is providing kind of a secondary redundant path for that connection. Other questions?
What equipment do I need if I want to get on the AREDN network?
So there is I have it towards the end of the slide. I have a link that shows all of the different devices that are currently supported for AREDN. Um, Depending on if you do or don't have line of sight access to one of the hilltop sites, that may change kind of what the answer to the question is. So some people that are currently on the network don't have direct line of sight to a currently active hilltop site. So what they do there is they have a MikroTik HAP, which stands for Home Access Point, and that is flashed with the AREDN software. And then you would likely talk to either myself or one of the club members who would be able to get you set up with a WireGuard tunnel that links into the Clark Valley AREDN server. And at that point, you'll be effectively connected via internet into the AREDN network and be able to start accessing all of the AREDN services. If you do have line of sight, then you can get either a MikroTik, a TP-Link, or a Ubiquity dish, and there's a large list of hardware. And either I or some of the club members can kind of help advise what equipment may make the most sense for the type of link that you're trying to do. That can be flashed with the AREDN software, and then you need to talk to whoever the site owner is that you're trying to connect to in order to get the correct channel information so that you can set the node on the right channel and then be able to connect up to it. Generally, when we have new users, the first thing we'll do is we'll put them into the ISP design tool that I showed earlier, just to kind of help see if they do have line of sight coverage, because that will also tell them what their initial heading and elevation needs to be when they mount their antenna. And once it's mounted and you're on the right channel and it links up, then you'll have a signal strength meter that you can use to kind of get the antenna fine-tuned. I'll showcase that tool in a moment when I go to do the live demonstrations. So here's kind of some live demos. So this is the home page for the server that we have up at Clark Valley. So this is what the actual AREDN graphical user interface looks like. So up at the top, we have, of course, the call sign of the station that is running the node. So in this case, we have the W6DGE call sign, and then the rest of the node name could be kind of whatever you choose it to be. A lot of times people will do their location and the radio they're using. So here in the Bay Area, for example, my call sign is W6DGE-Coop for Cupertino -LB5AC, which is the light beam 5AC, or that's the model of the antenna that I have in use here at home. Once you have that, you can have a little description here. You have kind of some basic information about uptime and system resources. You have your network information further down on the list, and then there is a node map that's also available that shows all the different nodes that are available on the network. Which, if I zoom out, oops. These are all the nodes that we currently have active in San Luis Obispo that are able to reach and talk to the server at this point in time. Up here we have all the different services that I have running. So one of the things that we have is the VoIP server, and of course, having a phone server is no good if you don't actually have a phone book of who you can call. So one of the things that we did is we implemented a phone book. What this does is it talks to a couple of different databases that are on the Arden network, and it effectively pulls information about once an hour to look for any new numbers that have been added to the network, any email addresses or notes that they put in there, and it gives a nice little offline page that you can use for searching up names or phone numbers. So, for example, if I search up myself, you can see this is my local extension for the Cupertino PBX, and this is how you would call the number from another network phone. So it'd be 78 plus this extension in order to be able to reach me from anywhere else on the Arden network. We also have the camera page right here. This is the camera page I was alluding to earlier. A couple of the cameras are currently offline due to some broken connections in the network that are in. We're currently working on troubleshooting, but you can see the Pismo Hills camera that overlooks Pismo and the Grover Beach area, and then we have the Lompoc camera that's overlooking Lompoc and kind of the hills around it. And on a clear day, a lot of times we'll actually be able to see rocket launches from Vandenberg, and you'll just see the rocket as a single blip frame on these cameras. The Grafana page was the network monitoring page that I was talking about earlier. So there's and for right now for the San Luis Obispo area, I only have a single dashboard set up, but I'm currently working on getting more comprehensive dashboards set up as well for the different hilltop sites. And what this does is it pulls data from all the different nodes on the network that I tell it to pull from. So there's a list of nodes that gets maintained that gets pulled about once every 2 to 5 minutes, and then it updates the data on the server, and then it displays it in a graphical way. Albeit because I'm up here in the Bay Area and it's trying to connect down to San Luis Obispo, a lot of times the pages take a little bit longer for me to load. While we wait for that one to load, I can show this one. So this one is the PBX or the public branch exchange server. So we have kind of all the different information here. So right now you can see we have 2 users online, 4 users offline, and then the trunks are the actual connections that go from one phone server to the next phone server. And this is a bit of a clunky way of seeing the data, and we also have a password on it that's not publicly available. So one of the things that we did is we pulled it into the Grafana page so that it's a lot easier to view the data, and it also refreshes real time. So you're able to easily see who is connected to the network or who isn't connected to the network. And then from there, you also have their phone number right next to them. So then you can put that phone number into the phone and dial them up. So you can see we have the 3 trunks online, myself connected to the network, and Dan also connected to the network. And for anyone that is on the Arden network and wants to have a phone number or extension, I'm happy to assign one to you so that you're able to then talk to other users on the Arden network via mesh phone, either locally or remotely. Ooh, Dan is calling. Hi, Dan. Hello. Yeah. I don't know how well everyone can hear Dan. Give me 1 second. let's try this. All right, try talking. Can you guys hear that at all? Barely, yeah.
I'll let you get back.
But yeah, so right now Dan is calling me from his home, and it's routing through the internet over to the Clark Valley server, and then from there it's routing through the internet up here to the Bay Area, where we have the Cupertino server, and it's making 5 different RF jumps before it reaches my house. I was on a phone call earlier with another user of the network, and we actually calculated that we were going through about 30 different point-to-point links to actually get up to the server. But the call quality was just as if I had him on a normal call on my cell phone, which is pretty remarkable. So these are kind of some of the main services that I currently have running on the mesh. Some users have put ADSB plane trackers on the network. They have kind of different camera servers. Some of them have put web-based software-defined radios that you can use to listen into local HF nets or local repeaters on the network. So in terms of services available, it really comes down to kind of the creativity of whoever the end user is and what services they decide to advertise on the mesh. But generally, if you can do it on the internet, you can do it on the mesh, because a lot of the infrastructure is the same. It's just an offline version of that. And then in terms of the links, you're asking about which devices to use or buy. So this is the current list of devices that are available to that are currently supported on the network. So as you can see, it's a rather extensive list. And some devices are more well-known and supported compared to other devices. Generally, what we recommend for people is getting a device that has more RAM, and getting a device that is listed in the stable category is pretty much guaranteed that every time we do a software release, the software has actually been tested on that device and guaranteed to be functional, and for the most part, free of kind of any major critical bugs that keep the device from functioning properly. The most common devices that people will generally use is the HAP for the local home internet connection if they don't have line of sight. And then in terms of the most common radios that I usually see, it's usually the LHG dishes, which are kind of around about 1 foot diameter mesh dish that connects onto the network, as well as the light beam and the nanostation nodes. So the nanostations are kind of small, rectangular like this. That'll give you about a 5 or 10 mile link, and then the light beams will give you about a 15-mile link. And the price point of the light beams is about $65 to $70. So it's a relatively low entry cost to get started on the AREDN network. We do also have kind of a surplus of some of the older devices that are still supported and functional. So for getting onto the network and just kind of getting started and testing out if you have a connection, a lot of times you're able to loan those devices out as well to help people get started. And then as their needs grow, they'll usually end up getting either a bigger dish or a more modern device that allows for kind of higher data transfer speeds and more stability on their connection. But it at least kind of gets them onto the network, starts to get them comfortable with the layout and the services and the functionality of the network, so that they can start to utilize all the features that are available for all the users. So that concludes the material that I had to cover, but if there's any questions, I'm happy to answer them.
On the different hills that you mount the antennas on.
Yeah.
Are you paying a per year contract, or are they all but donated the locations to you?
I can't speak for a lot of the South County sites because I'm not sure. A lot of the North County sites were generally co-leased in. So some of the sites we are paying leases for. Some of the sites were able to be there on donated space. So it kind of depends on site-to-site basis.
Yeah, I can answer for the Lompoc area. They're on our W6AB network sites, repeater sites. Those are mostly no fee. Some of them are on Chris's commercial sites where he has permission from the provider, so we're not paying for those sites. Most of our out-of-pocket expenses are really just for insurance for those sites at this point. And then we have the Plowshare site that we do pay a fee to the Forest Service for and to PG&E for power. But that's one of the few.
Thanks, Troy.
Kind of a manager in San Luis Obispo for the network then? The one person or many people?
Yes. So that's kind of one of the interesting things about the AREDN network so far is kind of when we first started to do it, it was really just get the devices online, see if they're actually functional, see if we're able to get these links up and running and kind of keep them stable and usable. More recently, as we've been having kind of some of the older hardware failing or giving us issues, we've been going through and upgrading some of the hardware and updating a lot of the hardware. I've been working a lot with Chris to update a lot of the hardware in South SLO County. Much of the hardware kind of in the Central and North SLO County still needs to be updated to a lot of the new equipment. And we haven't really had a single person per se managing it because a lot of the sites have different site owners with different site access requirements. So until recently, we haven't really had kind of one person managing everything. It's kind of been each person was managing their node and just maintaining the node on the same frequency as the other link that they're trying to connect to. Because one of the nice features of AREDN is with how the routing protocol is set up. For the most part, it manages the routing all on its own. So as long as you're able to get your node up and get it pointed, it then takes care of figuring out what the IP addresses needs to be, what the routing protocol needs to be, and then it manages all of that on its own. So there's not actually a too large amount of overhead that's actually required there for maintaining that.
I have a question.
Yes.
Yeah, K6ZAP, Mark here down in South County. Yeah, let's see. Is there any chance that we could get folks together to try to figure out if we get enough people together to do RF links, we can get over the mountain there and link South County with North County? Because we can't seem to do that RF wise currently.
So we do actually have a dish at Cuesta and one at Orchid Hill, except the one at Cuesta is pointed at Gravel Peak. So we don't have, if the dish at Cuesta were able to be rotated, chances are we may actually be able to get a stable link between the two sites.
Or add another one?
The challenges between Cuesta and Harris Gray, there isn't really all that many sites with clear line of sight between the two locations that we at least have AREDN on right now.
Yeah, that would be really nice though.
but that is one of the kind of long-term goals is completing that RF link between the two sites so that they're finally connected via RF as well as via the internet tunnels.
Mark, what community are you located in?
South County, Arroyo Grande. And of course, I'm part of the Central Coast Amateur Radio group down here. We have a repeater up on View Hill, which actually Dave there, our president, that's at your event there. I see him there. We're working on finalizing that Arden node and getting it up there on View Hill, so we'll at least have a something up that way to help out on the Arden network.
Yeah, because View Hill can see Neil, and Neil can see Orchid and Gravel Peak. So
Right, it's going north is the problem.
yeah. So yeah. Anyway, come to one of our club meetings. We'll talk more about it.
Thank you.
Hey, Mark, you should have come to the meeting in person.
I did come to the meeting. It's easier this way.
Mark's the treasurer of our club.
One of the things I did want to throw out there is one of the challenges we have right now is we don't actually have great line of sight from Cal Poly to any of our sites. We do have a link between the Cal Poly ham radio shack and Cuesta with the dish that's mounted on the satellite tower, but it's a very marginal connection, and we tend to have a rather large number of dropouts. So one of the long-term plans that's in the work is seeing if we're able to put a relay site either somewhere on the Cal Poly hill, kind of near the P at the water tower, that has better line of sight to Cuesta, or possibly on Radio Hill off of Highland to try and get the club and the greater kind of San Luis Obispo city area linked to Cuesta. And that'll also help solve the large shading coverage that's present in the city of San Luis Obispo from Cuesta, because otherwise a large number of users living near or on the Cal Poly campus, which is a good amount of the students, aren't actually able to easily connect into the Arden network at this point in time.
There's the new 900 megahertz mesh radios that are IP radios that might be kind of a bridge in some of the more urban areas as well. Orb's been testing the AREDN software on some of the devices that have been re-released.
They keep going out of stock though. I guess that means they work though, because people are buying them to test them. So, but yeah, those are given actually pretty promising results, especially in a lot of the areas where you maybe have relatively good line of sight coverage, but you have maybe one or two tree branches in the way. The 900 megahertz radios will be able to punch through and get you connected, whereas you won't be able to actually make that link with 2.4 or 5.8 gigahertz radios. So they've definitely been starting to be very useful and kind of well wanted on a lot of the networks, because it helps kind of fill in that last mile coverage, which is always the biggest challenge for most major networks, is kind of filling in that last mile more so than the point to point of the backhaul or the core of the network. Any other questions?
Davide, I have a couple of comments on
Yeah,
the campus.
go ahead, Ryan.
The link actually works pretty okay. From what I've seen, it's decently reliable. It's really the Cuesta to Clark link is the big issue, is what I've experienced.
Yeah, we still need to scope out what's going on there. There's supposed to be a antenna that links Clark to Cuesta directly, which at some point went off the air. So we're currently trying to connect into the sector that I showed earlier in the slide, but we're kind of right on the edge of that 120-degree coverage. So even though we do have a connection, it's very marginal. So that would be something that we want to take a look at and try and get fixed in the near future.
Students on campus are interested in connecting. We have hardware at the shack to borrow, and there's line of sight on campus from the dorms to Park Valley. I've been able to make that.
Oh, interesting.
I used to live in Yakutu too. If you have a west facing window, you can just like stick it up. Open your window to one RF and it will make the link.
So part of me wonders, actually, one of the projects that may be worthwhile is adding an additional sector at Clark Valley that points towards the campus. Because I don't want to use the point-to-point core link going to Questa for those connections, but I think we can probably find frequency space, and I know we have tower space on the pole to be able to mount a sector towards campus. So that may be a good project to do.
The main like northbound sector. The connection pad that works.
On the backside?
Yeah. It's like off the side of it. You can make the connection to the P as well.
Interesting.
On the P to Clark Valley.
Awesome. Anything else?
I think he's just showing off. He's probably doing moon bounce with 1,000 watts and bouncing it back down again.
Awesome. Well, if there's no further questions, thank you all for coming to the meeting and listening to the presentation.
Thank you, Davide. Yeah, very nice, Davide. Take care. 73s, everyone.
Have a good one, Mark.
Thank you.
I'm working on Sunday. Did I say Sunday? We just didn't say that. It's Sunday.